All right, algebras, let's see how you did with your warm-up today. So we'll go ahead and walk ourselves through solving these systems of equations. Graph the following systems, identify the solution. So for line 1, my slope is positive 2/3, and my y-intercept is going to be -1. That means 0 input gives me -1 as an output, and I know that from this part of the equation. So I'll start there, over 0, down 1, and I'll put a dot. My slope from this point is that my next integer coordinate is rise 2, run 1, 2, 3 away. The slope is what helps me find where my next coordinate is that intersects the grid lines. We call those integer coordinates. That's really all we can read from the graph, is where these lines cross at the grid lines. If I continued up at this slope, rise 2, run 3, 1, 2, 3, notice that's my next time that my line crosses at a coordinate. I can also count backwards, down 2 over 1, 2, 3, down 2 over 1, 2, 3. And you can see that constant rate of change is how we get the points all lined up. That's what makes it a linear equation. All right, let's talk about line 2. Line 2, I can see the slope is here, and that negative sign means that there's a 1 in front of the x, so that has a slope of -1. My intercept is here at +4, meaning if I substitute a 0 in for that equation, a 4 comes out. 0 in, 1, 2, 3, 4 out. That's where that graph hits the y-axis. My slope of -1 means I go down 1 over 1, down 1 over 1. Remember, your slope is your rise over your run. Here's where my intersection of my graphs is going to be. It's nice when it hits exactly on that coordinate. Then I know for sure I found the system. So my point of intersection is over 1, 2, 3, and up 1. So this is the solution of the system, where I go over 3, up 1. That's the point that these two graphs share. So looking at our next system that we are going to graph, this one is not so easy. Before I can graph it, I need to convert it to slope-intercept form. So I'm going to take this equation, 2x minus 5y is equal to 20, and I'm going to go ahead and solve for y. When I'm looking for slope-intercept form, that means that y is equal to. So my first step is going to subtract 2x from each side, and that's going to leave my -5y's equal to -2x plus the 20. When I divide everything by -5, my slope-intercept form is going to be y, which is all by itself. That's what I wanted. These two negatives cancel out, giving me 2/5 x, and here's my -4. So when I look at line 1, my slope is going to be this coefficient in front of the x. That means my line changes at a rate of 2 to 5. My y-intercept is going to be this here at -4, over 0, and up -4. If I put a 0 in for that x, that whole value, that whole term is going to zero out, leaving me with a -4. All right, so I start by graphing my y-intercept over 0, down 4. My next integer coordinate is 2/5 away. So rise 2, run 1, 2, 3, 4, 5. Rise 2, 1, 2, run 1, 2, 3, 4, 5 away. So I'll go ahead and take my straight edge and graph those integer coordinates. That's my first line. A positive slope of 2/5, a negative y-intercept of -4. All right, so my next line is a special kind of line, and we really want to make sure that we can tell the difference between these types of lines. So when I look at this one, this is a special kind of line with just a y in the equation. I know it's going to be a horizontal line with a slope of 0 and a y-intercept, or only a y in the equation. So my horizontal line is my one that goes like this. It's horizontal, just like the horizon. My slope is equal to 0, and my y-intercept is going to be the only output value that I have. See, y is equal to -2. So I know that every single time I look at an ordered pair for this line, I have an output of -2. It's never changing. That's why the slope is 0. So here's my intersection. If I go over 5 and down 2, that's going to be the point that works for them both. All right, when I solve the system using substitution, I have to be a thinker and look and see which variable do I want to isolate. Coefficient, coefficient, coefficient. This is my only one that has a coefficient of 1. That one's going to be the easiest variable to isolate. I'm going to rewrite each equation side by side. And when I have x minus 4y is equal to 1, by adding 4y to each side, I can easily get x by itself. 4y plus 1. So what I'm going to do is take this value for x, and I'm going to substitute it in here. So I'll write 2 times x plus 2y is equal to 3. Notice I'm not going to write x here. I'm going to write what x is equal to, 4y plus 1. And look at what this does. 8y plus 2 plus 2y is equal to 3. My problem before was I had x's and y's and x's and y's. Now when I substitute, I only have y's. That means I can solve this. 10y plus 2 is equal to 3, minus 2 on each side. So I get 10y is equal to 1. So y is equal to 1 divided by 10. When I divide each side by 10, I get a y value of 1/10. So I'm halfway there. When I look at what my solution to my system is, I know that some x value that's an input value is going to give me an output value of 1/10. When you solve for y, it goes in the y spot. All right, let's take a look up here. When I go to solve for x, my x value is equal to 4 times y plus 1. Well, guess what? Now I have a value for y. So my x is equal to, we can say this is 4 over 1. Multiplying fractions is no problem. Top times top, bottom times bottom. When I go to put 1 into tenths to add it, I can easily do that. And remember, your calculator can help you with this also. Adding fractions, you add the numerators only. And when I simplify this by dividing my numerator and denominator by 2, I get a value, oh dear, this is x. I get a value for x of 7/5. So I can put 7/5 in for that. This is the point where these two lines intersect. Let me ask you something. Is this something that we can graph? So when we look at this, we look at why we can need a system for solving it using algebra. This is not the answer that we could find here because they're not integers. All right, our first way of solving systems was using equations. Then we use substitution. On the back, you have something called elimination. When we solve a system by using elimination, instead of substituting one into the other, we're looking for some kind of zero pair. We're looking for one of the variables to cancel out. So when I look here, I've got a 2 and a 4 for the y, and a 3 and a negative. Now this at least has an opposite. When we talk about a zero pair, we're talking about the same coefficient, but opposite sign. So this 3 and this x are already opposites. What I think I might do is multiply this equation by 3, and then you'll see what happens. Here's my first equation. I'll rewrite that. And my second equation, when I distribute this 3, makes negative 3x, and then that's going to be plus 6y, and then 3 times 5 is 15. When I go ahead and I add, notice these 3 x's are a zero pair. My positive and my negative cancel out. 4y's plus 6y's is 10y's. And 6 plus 15 is 21. Divide each side by 10. And I get y is equal to 21 over 10. There's nothing I can do to simplify that. They don't share any common factors. 21 is 7s and 3s, and 10s is 2s and 5s. So there's no common numbers that can simplify to cancel out. So now what I'm going to do is I'm going to go back to any equation and substitute this value for y in. Because remember, I'm halfway there. I have my output, but I don't have my input. So what I'll do next is I choose this equation because to me it's the simplest. I'll go ahead and I'll write the opposite of x plus 2y is equal to 5. Now remember, you can substitute your y in to any of these equations. You get a choice of the one that you think is the easiest. I think putting 21 over 10 is the easiest here. All right, so my negative x is plus. When I simplify this, and what you can do here is don't be afraid of the fractions. That's why you have a calculator to help you. So what you can do here is 2 times 21 divided by 10. It gives you a fraction, 4.2, or decimal. You can go ahead and turn it back into a fraction by calling that x plus 21 fifths is equal to 5. Now I need to subtract 21 fifths from each side. So I get 5 minus 21 divided by 5. Order of operations is going to do this first and then subtract it from 5. So I do math frac and I get 4 fifths as an answer. So we'll come up here. Negative x is equal to 4 divided by 5. I'll go ahead and divide everything by a negative 1. So my answer is negative. Negative 4 divided by 5. Here's my value for x. That's my input. And remember, my value for y is my output. All right, so it's an interesting conversation. And what I want you to do is look back at each of the 3 types of equation solving and see which one that you prefer. So most kids like elimination. Some kids like substitution. Graphing is usually the one that is the trickiest. Some kids say they like that one because that's the one where the numbers are friendly, because you can't have a graph with these kinds of rational numbers or fractions. All right, so let's look at your task list for today. You've completed your warm-up, and you checked your warm-up with the video key. Now I want you to check your homework, and this is an important part. I want you to reflect on your missed problems, and I want you to put in here the things that you did wrong so that you can learn. You have your next lesson with the video. Check in with me for an activity, and then you have homework number 8 for homework tonight. Okay, keep on working.